Hello everyone. I'm very delighted to be here today. I think the conference feels so far very good. Thanks to Hasgeek for arranging this. With that said, let's get started. My name is Habeeb Rahman. I'm working at Hasgeek. The topic for today is Cloud meets Fog and Puppet, a story of version control infrastructure. I'm sorry, I could not get the title any longer. Anyway, so this is what we learned at Apigee, automating large-scale cloud deployment. So I'll be sharing some details about the tools and processes we were following and what we learned in that journey. Before we start, a bit about my company. Apigee is an API management company. We provide free tools for developers. We also have enterprise-level API management product, which is used by different enterprises across the world. Anyone using API developer tools? Okay. So nice to know. So basically, we make APIs better for developers and enterprises. That's the whole idea here at Apigee. We also have, we recently acquired a company called UserGrid, and UserGrid is to make building mobile clients for iOS and Android easier. So it's open source. You can actually find all the details in Apigee's website. There are a lot of videos, webinars related to APIs and UserGrid out there in apigee.com. You are welcome to visit and take a look. And in fact, APIs are very relevant to our talk today. So if you look at cloud and any providers like Amazon Web Services or Rackspace or Lightning, the way they provide the service is by giving you APIs, right? So if you look at a lot of cloud management companies, I'm sure you might have heard of these names like Scalar, the right Scalar. So what these guys will do is, if they make use of these APIs, then they will build their own tools. So that is the API echo space which we have right now, which the world is going through right now. So Apigee is about leveraging the API technology. Okay. So we were also using cloud management when we started. So it was, you bring up instances, you go to a web console, you bring up instances one by one, you attach different storage, then EIPs like that. So how many of you using AWS, Amazon Web Services in production? Okay, so just to set the stage right, if you look at AWS, Amazon Web Services, it allows you to create instances, cloud computing resource using API. You can either go to Amazon's Web Console, you can use any of these cloud management tools, or you can use Amazon command line tools, or you can use any of these libraries. Like in Java, there are libraries, in Ruby, there are libraries. So you bring up instances, you assign IP addresses, you attach storage, all these things. All these things are then we were doing it manually when we started. So, this was our day one. We were using a third-party web tool, and it was good. But the problem is we could not scale. Right? If you are talking about 1,000+ cloud servers instances, it's not easy. And we'll have deployment every week. Maybe your 10+ deployments every week. So it gets boring also at times, right? So if you look at this, this gives you a small idea about the different things we were doing manually. We were, if you know Amazon, there are Amazon machine images, right, which you use to bring up instances. And there are, packages you need to install licenses. You create EBS volumes. EBS volumes are nothing but network attached storage, which is another service by Amazon. Then you open ports, you create security groups, you attach EIPs. EIPs are just kind of standard, but it's different. You can actually attach and API to an instance. Later, if you want to move to a different instance, you can detach and attach the other instance. Right, so all these things we were doing manually. So my talk is about how we moved from this number of manual tasks to largely mostly automated state we are now. Right, so I'm not saying we are completely automated. There are quite a few things which we can still automate. We are working on it, but still we are good. So this was our take two, right? So I think a year back, one of our colleague in US, he started exploring cloud configuration management tools, and we checked Chef, Puppet, and finally we went with Puppet. We thought that it's better fit for our team and our culture, right? So Puppet, I'm sure a lot of you guys are already using Puppet. Can you tell me how many of you are using Puppet in? Okay, so Puppet is nothing but a configuration management tool where you can actually take a base instance, a base computer, to a desired state. If you want your base computer to Apache web server, you can apply these manifests. They call it as manifest. Just rules, it says install this package, have these users assigned to this instance. Then you apply this manifest. In Puppet terms, they call it manifest, and they apply this manifest to that instance, and you'll be in that desired state. Be it an Nginx server, be it an Apache server, whatever you want. So we actually started using Puppet. It was good. We also used Git for version controlling. I'm sure you guys are using Git. So what we use Git for is to manage the entire configurations and packages. So we bring these packages and manifest, Puppet manifest under Git version controlling. So Git gives you the history, what happened, when happened, and who did that change, right? So if at all you want to revert, it gives you that facility as well. You can actually go back to that previous version at any point in time, right? So this is where we were using Puppet and Git. And if you look at this, you'll see that installing packages and generating server configs. For example, we use load balancer. So we were actually using Puppet to come up with the server configurations. But still, you'll see a lot of these things are not automated. We still do a lot of manual tasks. So, that is where we actually found Puppet Cloud Provisioner. So we actually also got help from Puppet Labs, the creators of Puppet, and we use Puppet Cloud Provisioner. And Puppet Cloud Provisioner is in fact using a Ruby Cloud Services library called fork. So using this is where cloud meets fork, and we started using Puppet Cloud Provisioner. It is nothing but a wrapper around fork to bring up instances. I know that we had a talk around cloud formation. At that point in time, cloud formation wasn't that mature as a product, right? It was just came in. So we started using fork and Puppet Cloud Provisioner to bring up instances. And of course, Ruby is the whole language we were using. So if you look at this, we actually automated the whole thing. Only few things were pending here. That's, I think, we are working on, and I think as we go, we may automate those. So, what we have is, in our case, we are a managed service provider. We manage the whole API management product for the customer in the cloud, right? So we have a customer in a YAML file. So YAML is a simplified version of JSON or XML, right? So it will look like this, right? We'll say this is our configuration for so-and-so customer, and just run this Ruby script, and we have everything ready, right? So even the Puppet will be installed automatically. All these security group creation, port mapping, everything will be done. So this is just, it's just that you're giving all these variables, saying that, okay, this is the key file, this is the image you want to, this is the instance type. Anyone who worked on Amazon know that there are different instance types like M1 small, C1 medium, M1 large, like that. So we'll keep all this information in this YAML file, and we'll run that script. That's it. We have our customer instances ready. All right. So the beauty of it is you can actually reuse this. Once you have this in Git, tomorrow you have another customer. Maybe you need to change a few things here and there. You can pretty much reuse the same thing across different customers. Sure.
So your choice of fog compared to alternatives like cloud, clouds.
Right. So
what were your reasons for choosing fog?
Yeah. So actually, it's like we happen to meet fog. So nothing against libcloud. I don't think libcloud or delta cloud, jclouds were mature at that point in time. I was talking about CloudFormation also. CloudFormation was very new at that time, right?
But
so
you're only dealing with Amazon cloud, not.
As of now, we are only using with Amazon cloud. But yeah, so I'll come to that. That's one of the features of fog. We can actually use fog across multiple vendors, right? So this is our YAML file where we can bring up instances easily. So basically, Git, the version controlling mechanism tool, manage both Puppet configuration and cloud deployment. The YAML files and the manifest, Puppet manifest, both are managed by Git. All right, so this is a very high-level view of the whole thing, right? So we put these YAML files in the Git, right? And the Git has this post-receive hooks, right? Which means that whenever there is a commit, they call it commit. Basically you're saying that, okay, let this change happen in this repository. Whenever there is a commit, you can actually have a post-receive hooks, which will copy this repository to the different Puppet masters we have in different regions, right? Now then we'll run that script from whatever region we want to bring up the instance. So if you know Amazon, there are, I guess, 5 or 6 regions as of now. So we'll have, for us, we have Puppet masters across different regions. So once you push anything to the Git, it will go to the corresponding Puppet master. Then we'll run the script. So like I said, we have fog, and we also have Puppet Cloud Provisioner. Then we have a easy deploy, which is a wrapper script around all these, which creates the whole thing, which keep everything in sync, right? Then it bootstraps the cloud instance in Amazon. Once it's up and running, it pulls configuration from the respective Puppet masters. So this is a very high-level view, but I think this gives you an idea of what we do. All right, so like I said, we are using Git hooks to do 2 things. One is, before committing something to the repository, we need to parse the Puppet. I mean, we don't want someone to do a bad manifest committed to a repository, right? So we do a Puppet parser check before the update. We also do, we don't do this as of now, but there is a tool called Puppet Link. Probably you can explore further, which actually does these things a lot more better. So, and afterwards, a post update in Git, that's a hook, will sync these repositories. For example, the Puppet repositories with different Puppet masters across the region. Okay. And now a bit about the Puppet. I know that you guys know about Puppet, so I'm not going in detail. But what we do maybe differently, I'm sure a lot of companies are doing this. We use Git branches for Puppet environments. So we don't have a separate test environment. We have a single Puppet master. We use different Git branches to separate it out. So for example, if you have I'll give you an example. You want to add some features to existing manifest. You don't definitely want to do it in your production environment. So what we do is, we create a new branch in our Git repository, then we push it to the central repository. Then when we bring up instance, we say, use that feature X, right? Now, this new instance will actually get all the new configurations, new manifest from the Git repository. Then we'll come up with that version of Puppet manifest. Okay, now, so like I said, with single master, Puppet master, you can have test, dev, production environments. Then manifest and files data. So basically, if you look at Puppet, you have the basic rules, the manifest. You also have data, which says, you want to use this configuration file. So we separate it out. We don't keep both things. You can actually keep both manifest and this data in a single repository, or in single repository. We don't do that. We rather separate it out for ease of management. Another thing is, like I said, we have Puppet masters per AWS regions. Okay, now these things we have started using. I'm not sure how many of you have heard Hira. This is a tool which helps you to separate out the data again. I'll give you an example where, as of now, we are coming up with our, one of our versions or one of our product. What we do is, if at all there is a new update to that product, all we have to do is to go to this Hira repository. There will be a fh version, that product version. We just update it, then restart the Puppet. Right? So basically, we don't touch anything in the manifest. It's completely separated out. So this is something you can explore. I think from next version onward, they are trying to integrate this with Puppet. Sure. Yeah. I mean, if at all you want the change to happen immediately, true. Yeah, so if at all you want to change it immediately, yeah. Otherwise, of course, it will run every 30 minutes. Or you can, cron tab it whatever you want. That's right. So I said, I mean, we restart it because we want to see the changes, validate it, then go to the next thing. That's true. So like I said, Hira, they are trying to integrate it with the core Puppet from next version onwards. Okay, so now why fog? We happened to meet fog, like I said, and we started using fog. So few of the reasons why I like fog is, one is cross-service compatibility. You can actually use this with, different services like compute, DNS. We actually use, we are coming with a version of this CC deploy script where we create all these DNS entries as well using fog. So you have multitude of services like storage, compute, DNS, load balancers, MySQL service, everything which you can control using fog. There are APIs in fog. Now another thing is avoid vendor lock-in. I mean, this is a debatable topic, but as of now, fog supports different vendors. EC2 they support, Rackspace they support, SliceHost, Linode. These are different vendors, cloud vendors, fog supports. Now another thing I like about fog is the power of Ruby, right? So we'll come to Ruby later. So this is how you install, if at all you are interested in fog. Fog is a gem. You can say, if you have Ruby in your laptop or your server, you can install using gem install fog. Then in your Ruby program, you'll have to require this package, require fog. Then there is a .fog file in your home directory. That is where you keep all your, AWS account details. So the fog automatically fetch your cloud details from that file. Now, one of the things is that at first there are not many good documentation out there for fog. But I learned that you can actually look at the test suites, and actually learn a lot, about fog. So it's because of Ruby's, or I think there are a lot of languages using this approach now, test-driven development, TDD. So if you go to this folder, you'll find the way they have, you can actually use fog in your environment. So it's very, very easy to get started if you look at all these files. Okay, and fog also has a command line. You can say fog test AWS, which means this will take the test AWS account details from the fog file. Right, then you can play around. You can create instances in the command line itself. And this is another example where you actually look at the different vendors. If you see here, we are using similar command to bring up instance in Amazon, also in Rackspace. And here you say, you're creating with this AMI. Here you're creating with Rackspace on AMIs and flavor IDs. So basically, the idea is that you can use the same command and create instances across multiple cloud vendors. And we were discussing about this. There are a lot of open source fork alternatives. Probably, if you're interested in, for example, Python, you can use libcloud. And I know in Amazon they have a package called Boto. I'm hoping someone is using that. That's not vendor independent, but just Amazon, Python library. Then Java, there is JClouds. In Ruby, you have Delta Cloud. That's a new Apache project. I think it looks interesting, something to explore. So again, why Ruby? I used to program in shell scripting. For some reason, I didn't like Perl, but the time I started using Ruby, I liked it. And this answers why I liked Ruby. I think you should, if at all you're not using Ruby, I think you should start using Ruby because it's productive and it's fun to use. So this is the code from Matsumoto, Mats, the creator of Ruby. So Ruby is definitely fun to program and fun to work with. It's very productive. All right, and I also suggest you to watch this talk by Ajay Gore. So this is a nice talk. Probably you can watch this online. This also gives you the different, especially for us sysadmins, the different areas it's being used, the Ruby being used. So I know Ram is smiling. It's his ex-colleague. Right. So if you want to learn Ruby, there is this IRB, that's Ruby Interactive Shell. You can do whatever you can do with the program in IRB's shell prompt. And I know that there is an IRB alternative which is called PRY. I didn't explore much, but it looks very interesting. So you can actually install it it's a gem, using gem install PRY. All right, so one of the things interesting about fog and Puppet is the layers of abstraction, right? It gives you an abstraction layer. It's independent of, for example, if you take fog, it gives you the cloud abstraction. It's independent of vendors. And say, for example, tomorrow you want to bring up your DR environment in a different vendor. Fog-like libraries makes it easy for you. I'm not saying it's you can just say use rack space, but it makes it easy for you. So fog gives you that cloud abstraction, and tools like Puppet gives you OS abstraction, right? And again, it's not like you can just switch to say Ubuntu from CentOS, but it makes it easy. All right, so I think we are reaching the end of the talk. So these are a few notes to myself. Hopefully you'll get some points out of it. So one thing I've learned is that if you look at where we were and where we are, I never thought that we would be able to reach this stage because it was like a pile of manual tasks. So we actually started small, then we actually iterated. So I think it's a very, nowadays in software development they call it agile, but in sysadmin, what do we call it? It's we need to start small, then iterate, reiterate, and reiterate. I think once we do that, I think we can do wonders. Right. Another thing is there are a lot of fights over these tools. Right? Someone says Chef is the best, and someone says Puppet is the best, CF Engine. There are a lot of fights, but for us, we selected the right tool for us because we thought that it suits our team, our culture. So I encourage you to do the same, to evaluate not because something is right for someone else, to use it because it's right for you guys. All right. Another thing is, sure.
How do you figure out what fits your culture?
See, for example, I'll give you our example, right? We were like just operations guys. We didn't have much experience in Ruby. So if you look at a lot of startups who are Ruby based, Ruby on Rails based, they use Chef because they know Ruby, and the language Chef cookbooks are written is Ruby. Whereas Puppet has their own DSL, which is kind of easy, right? So to learn. So we started with, we weighed that point and we thought that, okay, Puppet is suited for us, right? Sorry?
you're not developers, you're tech systems.
Exactly. Maybe you can learn. I know that Chef is also widely used. It's good. Probably we can learn, but it takes some time. So we went for Puppet. So another thing is, something I learned that and whenever you design a software, and it holds good for softwares as well, we need to make sure that it's operations ready, right? I mean, you cannot think of making a software product operations ready after everything is up and running, right? As in, when you go into production. So the day when you design the product, you have to make, this is not something for the sysadmins, but which is something good to keep in mind, and we can probably advise our architects and designers out there, right? So with that said, I think I'm done. These are the few pointers to get started. Yeah, that's it. And just in case interested, we are having.
I want to go back to the slide where you talked about your Puppet setup. And you mentioned that you have a Puppet master for each region.
Yeah. That's true. Oops. Yeah. Yeah.
Why do you have this thing?
So this is mainly because of scalability. We have like around 1,300 plus instances, right? So we don't want the Puppet request to go across regions to fetch the manifest and the packages. So mainly because of that.
Are you worried about the cost of data transfer?
Sorry? Yeah, and then we thought that it will be much faster, the whole thing. I mean, I've seen that sometimes if you have too many packages in your Puppet master, even within the region, it's very slow, right? So we don't want to be in that position for, say, Europe region. So we wanted to make it faster. So from the day one, we had different Puppet masters for regions.
And has it ever happened that you not be able to access a particular Puppet master in some region because of blockages?
Touchwood. No, we did not have that situation yet. So you mean problem accessing a Puppet master in a particular region, right? We didn't have that. But still, I don't think that will be a problem. I don't think that will create a problem because if at all you don't have to have a new change to be done, a new package to be installed, it will run fine, right?
And one more question, maybe it feels stupid, but what if the Puppet master goes down? So what is your strategy there? Like, you have so many instances.
Yeah, so one of the things is that we will try to bring up a new Puppet master as soon as possible. We have all these things automated, as in we keep these Git repositories in S3, right? So we can actually bring up this new instance. We actually puppetize the Puppet master also. Okay, so we know that how to puppet the initial thing, then we bring up the instance. So when it runs, once it runs, you have a new Puppet master. So yeah, puppetize the Puppet master. Yeah, we do that. But initially, bit of things you'll have to do manually, but the other things are puppetized. As of now, we monitor the processes. We don't actually monitor the logs as such, but we monitor the process in each individual Puppets, servers and agents. We monitor the individual process. But yeah, I think there are better mechanisms to actually monitor Puppet by looking at the var lib Puppet. There is file which will be updated every time the Puppet will be run. So we don't do that as of now, but yeah, there are mechanisms. Any other questions? Sorry? Yes. We do all. Okay, so we validate. Once you have an instance, and then you install. For example, if you have Apache server, you validate that. For example, you access the site. We have a portal, for example. So once you bring up the instance, Yeah, we don't have that situation. For example. Okay. We never been into that situation, but. So probably I'll repeat that question. So what he said was, if you want to, upgrade some instance and you have to do it in like 20,000 or 2,000 servers, how do you make sure that it's being installed in all these servers? Right. So probably even write a script. I don't think Puppet.
Sure that installation succeeded or not. If the Puppet runs succeeded, that doesn't mean
Yeah. So mcollective might be an answer there.
Depends on how you write it. Right? You can
actually tell it to install a specific version also, right?
Yeah.
So if you give ensure this version, it will install that one only. If your YAML repository has that specific appointed package with you, and if your code will say ensure this
Install
version is there, it will only install that version. Yes. Just speak up a little bit.
After 1,000 servers, there is some notification and update happens. This is given. How will we find out that which are the 1,000 servers that the government needs to find which are the
Collective, that's something else. You can use MC shell to actually query and see which node has that which node has that specific.
Exactly. Yeah.
So
even
stuff like that. So there's a lot that you can do with MC also.
Yeah, that's right. So we are actually using MCO. So for example, you can say what is this, the version install, package install in all these different servers. Yeah, we are also using mcollective for that. In our latest Puppet deployments.
And you want to see, right, which servers that are getting installed or not on, right? So you have 500 servers, 250 of them fail, that's few. And you want to see now on which servers it will fail, right?
I think iterative will come back and maybe succeeded in 50 servers. It doesn't even know 500 servers are.
If it has Puppet installed, then it will, right? That's how it works. It's in you have to define a specific, like you can actually tell MC shell to check for which node has a specific attached to it or not, stuff like that. So you will come down definitely with
mcollective. Yeah. So you guys are using mcollective? Oh, okay. Yeah. Okay. You are using. Okay. Yeah. We are also started using it. So it's a nice tool. So yeah, like you said, we are also using. Say for example, you can say what is this version of this product. So it will show you. Okay. In all these servers which are in that group, it show you the version of the product. Oh, is it? Okay. Why is that? I know that.
I have not talked to them really because it's another agent listening for the purpose of Puppet specific change.
I agree with that, but let's assume this. You have some kind of a RPM dependency because of which you want like certain packages that are failing to install. And this requires you RPM minus E some package name, RPM hyphen I some package name. Doing that across manually across 500 servers is going to be a pain in the ass for some time. So
that's what I'm talking about Gopal's talk, but he talked about exactly he wrote a Python script to do a parallel SSL connection.
now we start debating about this parallel SSA or is I rather not build.
I know.
Not start copying over keys across servers just to do this than say ensure and
So I know that.
Ensured and collected ensured is not the problem. The problem is collected is an agent running on every machine in my cluster and exchanging status messages all the time.
It's not that overhead.
No, sending status on the cluster has to exist. Sending
It has to be started around this. I'm not sure if you had any major overheads because of this specific thing. Because we running across almost as 100 users over now and trying to do that.
So any other questions? I think we can definitely discuss. Yeah, it's I think we are having a talk on M Collective, so probably he might much knowledgeable. So anyone using Rendeck? There is an orchestration tool called Rendeck, which is I think based on SSH. So yeah. So yeah. With that said, if no more questions, any other questions? Okay, thank you guys. Appreciate it.